Greetings and welcome. In a previous video session, we have discussed about the theoretical concept for forces acting on a submerged body. In this video session, we are going to see a numerical on the submerged body in order to calculate lift force, drag force, resultant force and direction of resultant force acting on a square plate moving in a stationary air. Statement of the numerical is given. A square plate of side 2 meter is moved in a stationary air of mass density 1.2 kg per meter cube with a velocity of 50 kmph. If coefficients of drag and lift are 0.2 and 0.8 respectively, determine lift force, drag force, resultant force and direction of resultant force. Situation in the numerical is shown with the help of diagram. This is a plate with a side 2 meter by 2 meter moving with a velocity capital U in a stationary air. So area of the plate is mentioned over here. Remaining parameters are given. Density of air, that is rho in kg per meter cube. Velocity of the plate is given in kilometer per hour. We have to convert that into meter per second. For that we multiply the value with 1000 and divide it by 3600. So we get velocity of plate capital U in meter per second. Coefficient of drag and lift are given in the numerical statement, that is value of CD and value of CL. First of all, we see the calculation for lift force. To calculate it, we use the formula FL is equal to CL into half rho A capital U square. Here all the values which are mentioned in the statement, these are put. Value of coefficient of lift, half, value of density, value of area and speed, meter per second. After the calculation we get the lift force in Newton. Similarly, we calculate the drag force by using the formula FD is equal to CD into half rho A capital U square. Here also we have all the parameters, known parameters. So putting the value of CD and remaining half rho A and U. After the calculation we get the drag force in Newton. To calculate the resultant force, we use the value of lift force and drag force, because we know that here to calculate the resultant force we can use the Pythagoras theorem. So here we can see this is a horizontal force drag force, vertical force FL. So this FL component we can take here. So formula to calculate FR will be what is equal to inside the square root of FL square and FD square. So as we have got the values for FL and FD, we put that these values here. After the calculation we get the resultant force in Newton. Then direction of resultant force with the horizontal or direction of motion is given with angle theta. To calculate theta from the trigonometry, we can take tan ratio between horizontal side and vertical side. So tan theta is equal to what? FL means lift force divided by horizontal component FD. Further, in order to calculate theta, we take the tan inverse of FL by FD. Putting the value calculated of lift force and drag force over here and doing the calculation, we get the angle value in degree, that is what? Direction of resultant force with the horizontal. The last is power required to keep that plate in motion. So power, we know that it is a product of force and velocity. So here we take into consideration drag force in Newton and velocity means plate velocity in meter per second. Calculated value of drag force and value of speed or plate velocity in meter per second. After this calculation we get the power in watt. Further, this watt we can express in the term of kilowatt by dividing this watt value with 1000. So this is a power value in kilowatt. So this was the numerical where we have seen a procedure to solve a problem where we obtain the value of drag force, lift force, resultant force, and direction of that resultant force with the direction of motion or horizontal, that is angle theta. Let us meet in the next video session. Thank you.